Hello everyone. I'm Khouloud Touil, and today I'm here to present for you with my colleague Kevin Hilman how patches grow up and go to the KernelCI school. So a small introduction. Let's start with introducing our company, Kcidb. It's an embedded Linux consultancy company. We are based officially in Nice, south of France. So we work together almost 40 engineers, and we are working basically on open source domain. So we are top 20 Linux kernel contributor. We are working also on AGL, which is the Linux Foundation project. We keep contribute to U-Boot, Zephyr, Yocto, and we do a lot of automated testing. So I'm Khouloud, and I'm junior software engineer. I'm based in France, and as I'm presenting for you this, so I'm a KernelCI contributor. As for Kevin, he's a co-founder of Kcidb. He's also a Linux kernel developer as well a maintainer. He's the co-founder of KernelCI project, but unfortunately he's based in Seattle and not in Nice. For you, Kevin?
So let's talk a little bit about just a little background on what we're going to talk about for KernelCI. So a little bit of what the project is. So KernelCI is kind of three things. First of all, it's a free service for testing the Linux kernel. So this is the part you may have heard of before. So KernelCI.org has been around for several years now. So that's kind of the service that we provide, but behind the service is all the software that runs the service. So KernelCI is also an open source project where all the software we use to make KernelCI.org is publicly available and as open source project that we can use to collaborate. And KernelCI is also a collaboration hub where we can focus on what we're doing next, how we can improve testing, especially hardware-focused testing for the Linux kernel, and various tooling around the open source automation. So KernelCI is all of those things. And we recently became our own project under the Linux Foundation last October. So there's also a little summary of our mission statement focused on just improving the Linux kernel quality. So as a Linux Foundation project, we launched with this group of founding member companies, and these companies are working together under the Linux Foundation project now to kind of advance the state of KernelCI and work on what's next. And so that's a bit of what we're going to be talking with you about today.
So our main topic is how Apache grows and goes to school. Well, we have a newborn baby, which is just an idea in the mind of a developer, a maintainer. He develops that into a patch. So we are passing to his total years when he sends that to the mailing list. So there he will fall down a lot. While growing up, he needs to go to school. Well, he will land in maintainers tree. There, he will learn how to play with others. Maybe he will get teased a little bit, but he needs to survive. Then we are a little bit bigger, so it's for high school, which is Linux next. Well, there, these years it's gonna be a little bit difficult, so he will fight with his friends and find a way to be integrated. So then after the high school, he will go to university. Here we are talking about mainline, and there he will make new friends. But finally, he will graduate in a long-term stable, and maybe he could get a commercial job. For you, Kevin?
So this is a little bit of the flow, kind of a high-level flow of how KernelCI works, all the way from our student developer all the way through our pipeline. So we're going to use this slide throughout the talk to kind of highlight, and we're going to highlight each of these steps along the path. So as a path flows from the source code to how we build it, how we run it, how we get results, where we store results, how we analyze results. So we're going to go through each of these step by step through this talk. So for our cheesy little metaphor here, these will be our school classrooms, and we'll go through the various classrooms as we go. So let's start with the beginning. Let's start with the source code. So where does all the source code come from? So here we have multiple ways of getting source code into the KernelCI process. So we can get patches right off the mailing list. We can get patches and git commits right out of for multiple maintainer trees. So we track quite a few different kernel maintainer trees. And from there, we're also getting patches from Linux Next, from mainline, from the stable trees. So there's multiple places where the source code enters the KernelCI pipeline. And at each phase of the patch's lifecycle, it goes through KernelCI. So by the time it gets from the mailing list all the way up to mainline into stable tree, it's actually have gone through KernelCI multiple times. So one of the things we're looking at doing next, so I mentioned here patches from the mailing list and from trees. Right now, we're not actually testing directly from the mailing list. We're testing from the maintainer trees and from Linux Next and mainline. But one of the things we'd like to do as a next step is actually test patches in series directly from the mailing list. And there's actually some really cool tools coming out of the kernel maintainer community right now, like B4. That can easily get patches right from the list and the mailing list archives, and we can start using those tools to easier test patches right from the list. And also, the more compute capacity we add, the more kernel builds we can do. So we could actually start building more trees. So moving on to the build classroom. As you saw, we do quite a few different kernel builds. So we're building several different kernel trees, and so for each of those kernel trees that we build many different configurations. So we build multiple architectures, we use multiple compilers, we do multiple different def configs, and we have this various inside of our source code. We have a YAML config file that people can change as they want, so we can do different customizations for each tree. So for some trees we might not build for all architectures, and for other trees we might. And the kernel build process includes not just building the kernel, but also building the modules and also building the self-tests that come as part of the kernel. So to orchestrate all of this, today we use Jenkins. We have a primary Jenkins instance, which actually kind of manages a lot of our build resources. So we have static VMs and cloud VMs. And we're starting to use Kubernetes actually to manage the cloud VMs. So on average, we're doing around 2,000 builds a day. That's on average. Some days it's a lot more, some days it's less, but that's quite a few builds today. So we need quite a bit of compute capacity to manage all those. And as I mentioned, the cloud compute, now that we've become a Linux Foundation project, thanks to both Google and Microsoft, we now have quite a bit more cloud compute capacity. So we're scaling up our compute capacity using Kubernetes actually to do a lot more builds. So a little bit about some of the build tools and data that we use. So we've created some base Docker images for each kind of architecture and toolchain combination. And that allows us to build kernels in a consistent environment for each architecture and for each toolchain. we have this tool called KCI build that actually kind of wraps up a lot of the build logic into a Python library and a command line tool. That manages the cloning of the repos, the building of the kernel, the modules, the self-tests, the install step, and then publishing the kernel to our storage area, which we'll talk about in a little bit. So down at the bottom, there's a URL here for the KernelCI core repo, and that's where all these scripts are published and maintained. So you can use those and test those and send pull requests and stuff against those tools as you want. As far as the data that comes out of the kernel build process, we generate all the obvious things, so the kernel images that are built, the symbol maps, and so on. But these kernel builds are also generating, for some architectures, there's quite a few device tree binaries that are built as well. The kernel modules, the self-tests, as well as all the build logs. Those are all artifacts of the kernel build that we save and we store in as our artifacts. As well as that, we track a bunch of metadata with each kernel build. So we're tracking the image size per section. We're also tracking the build time. So we track how long the kernel takes to build. We track some information about the host platform, so we know for each of the different VMs that we're building on how long it takes. We keep track of the compiler errors and compiler warning counts and so on. And so we're tracking a lot of this metadata that we also carry along with the builds, and we store in the database to deal with later. So this is just an example of some of the build metadata that we keep, that we track for a given build. So here, for example, we have a bit of information about the build machine itself that was used. The number of build threads, so the number of parallel, essentially the make JLevel that we can use, the little bit of information about the compiler, all sorts of things. So then we can see the tree, the kernel version, the git commit, all these things. So all this stuff we track per build and we store in our database so that we can analyze later. So some of the things we'd like to work on next in our build step, like I mentioned, we're working with Kubernetes now. So this has just begun where we started to migrate some of our infrastructure to Kubernetes, but this is definitely an area where we could use some help. We are learning a bit about Kubernetes as we go, but it's definitely not something we are familiar with as a team. So if anybody wants to help KernelCI and has some good Kubernetes experience and kind of cloud DevOps experience, we would be grateful. We're making a lot of our I mentioned our Python tooling. We're kind of reworking a lot of our Python tooling to make it more reusable in library form as well as command line form, and migrating it to Python 3. I mentioned we're using Jenkins, but we're also kind of tired of Jenkins in many ways and having a hard time keeping it maintained and keeping it upgraded. So we started to look at some other CI/CD pipelines as well. So if any help in any of these areas, if you want to help KernelCI, we could use help in any of these areas. So please let us know. Okay, so moving on to the next classroom, let's talk about how we run the tests.
Okay, so the third classroom for us now, it's the run classroom. Well, for that we need a lab. So for a KernelCI project, we have almost 10 distributed labs. In Kcidb, we keep maintaining 2 labs. So let's define a little bit what lab for KernelCI means. Well, it means there is a test platform that manages several different types of hardware. So for test platforms, the missions are to schedule these hardware, to allocate resources, and to check dependencies. So as an example, we are using Lava, which is an open source platform developed by Linaro. Also, there is Beaker, which is used by one of our members, which is Red Hat. So the purpose of KernelCI is to test on very different types of architectures. So for now, we are supporting ARM, ARM64, x86, MIPS, and RISC-V. For that, here is an example for these architectures with boards. Also, not only we don't use only like hardware. We are using also VMwares as KMU. Also, we have different types of boots. So in here, as you can see, we are testing on U-boot, fastboot, grub, UEFI. Also, new types of U-boot been added lately to our labs, core boot and depth charge. Well, next, we will talk about how to really run these tests. So after the build, there is some build artifacts are generated. What we need from those artifacts are, of course, the build images to be tested, but also the DTBS JSON as an example in here. So, Kevin? In here, as you can see, an example of a DTBS JSON file which contains the name of the exact DTB. Well, in this example, we have just one board, but in other examples, you can find a very long list with the different names. So it depends on the architecture. As well, bmeta.json file, which contains contains the metadata information of the build. So if you can see next, architecture in this example is RISC-V, build environment is GCC8, also the Git branch and the Git commit, which is the SHA-1 of the patch to be tested. Also, the status of the build, which is pass. So to generate a tested job, we are using a KCI test tool, which is a Python tool developed by KernelCI community. Well, to generate, we need the test plan. So which type of tests we want to run, the lab, because each lab have different types of boards. Well, the storage from where to get the artifacts, a user and a token. After generating that test job, which is a YAML file, it will be submitted through KCI test submit tool. Also, we need a lab, a user token, and then the job definition, which is generated previously. As in the bottom of the slide, you can find the link for KCI test tool. So next, we will have examples of a job YAML file. So in the first part, we have the metadata we spoke about previously. It's the same that in the meta.json file. Then this part, which is contain the deploy part, so the URLs of the kernel, the RAM disk modules, and DTB, the boot section to define which type of boot we are using. For example, here we are using U-boot. And then the next part, which is the test itself. So in this example, we can see which it's a sleep test plan. So for now, we don't have a lot of different tests. We keep doing 4 kind of tests. Like so the other test tools are power suspend resume, which I'm presenting in this example. Then we can find media, which is V4L2 compliance, graphics, IGT, and an USB test, just smoke test. So, well, in this section, the run next, we need help more to create new tests, so new variant of tests. So what's in progress are self-test and KUnit. Well, we want LTP, size bot, size call, or reproducers, XFS test, and you can contribute with your favorite test suite. Well, we move now to results. So after running these tests, we are having results. So in this, we can see we have different N labs, so different labs distributed. Each lab have his own way to send results data. So either via REST API or structured data or even command line tools. For structured data, we keep giving the example of Lava callback. So where this data goes, we have either KernelCI backend, which is a tool to store this data and analyze it. It stores its data locally using MongoDB, or to the Kcidb, which is in progress, work in progress. And the difference between Kcidb and KernelCI backend, that KernelCIDB store the data in the cloud databases. So in the bottom, you can find the API for the KernelCI backend, and please have a look. Okay, so let's see an example of result tests. This is from Lava callback, an example for Maison Kcidb 3. First, this is a generic format. So we have the actual device, the lab name, so from which lab we are receiving this data, results and logs. So next we will have an example of the results expanded. Yes, this is an example of a test suite for the message, and you can see next we are having, for example, the name of the test case and the result it's passing. Okay, what's next in results? So we are needing more. We need to scale more data. So we are receiving lots of data, and we need to develop new tools to have something in common and generalize it for different types of labs. Okay, so after receiving those results, we move to the next class, which is store. Well, we have in the store class, we are receiving from both sides results and build. So as we can see, the build artifacts are, it could be build logs, the kernel, the RAM disk, the rootfs, test images, DBEs, and metadata, as we previously seen an example of the Vml file. As for test results, the run artifacts, we have the test results, which are stored in MongoDB. We have boot logs. So in the test, we have two types of tests. So boot tests, we just test if the device is boot, or we have as I mentioned, different types of tests. So in this example, we can find a boot logs for a Maison board, and this is in the type of text format. But not only that, we have also another format, which is HTML format. In the next example, we'll see a test log, not a boot log, in a HTML format. Well, if you visit KernelCI storage, KernelCI.org, you will find a lot of different data and build artifacts and run artifacts as well. So what's next in store? As we are receiving a lot more data, so we need a bigger storage to handle that size of data. Well, we do not only store data, but we do analyze also these data, which is the purpose of KernelCI. So next you will see the KernelCI backend, which receives data. Then it analyzes if it's built results. So it's gonna be pass or fail. If it's test results, we will have test pass or skip or fail. So if when it's fail, it could be always failing because that platform can't support that type of test, or it's a new failure. So when it's a new failure, it's causing regressions. We need to track that regressions, and by doing that, we are doing bisection until we get to the bad patch or our bad kid. And of course, we have to report the bad behavior. So reporting. Okay, what's next in analyze? As we are having more data, we need to get deeper analytics. For example, which are the platforms to fail the most? Which are the trees of maintainers that have a lot more problems than others? Or which one that keep failing boots? Well, we can have different types of analysis and statistics based on this data.
Okay, our next and our last classroom in our KernelCI school is the reporting. So let's talk about that a little bit. So for reporting, what we have today is primarily email-based reporting. So we're doing email reporting for builds and for test reports, as well as for bisection reports. So the next few slides are just going to show a couple examples so you can get a little flavor for what this looks like, but you can also use our web interface to find some of these and look in more detail on your own. So for a little flavor, the example here is a test report that you can see. This was on mainline master. It tells a little bit about what it is, so you can see it's V58RC1. It tells the test plan. Our test plan, it's called, our baseline test plan is kind of like a minimal set of tests after a platform boots to make sure we can actually run other tests. So we can see from this regression summary that actually 3 platforms actually have new regressions on this kernel release. So you can see that 0 out of 1 tests actually passed here. So you see the platforms, the architectures, the lab, the def configs, and so on for each of these platforms that actually failed. And then you can actually go to for more details, you can actually click on the links here and go into the web interface to get a little bit more details, and we'll show you some examples of the web interface in a little bit here. So at the top here, you see a summary of the platforms that failed. Farther down in the email, it'll give more details for each of the regressions. And you can actually see even segments, little fragments of the logs to show what happened and why it failed. So that's just one example. Another email example is when we actually find a new regression and we're able to bisect it down to a specific commit. We'll send an email out that isolates the commit itself that caused the problem. So we'll send out this bisection report. So this example is from the same tree. It says this particular test plan had a problem on this particular platform, and then it goes on to give a little more summary. And in more detail, it actually will show you the commit that actually caused the break. I removed the author to avoid public shaming here. And then also it'll give you the git bisect log, so you can see where it actually started, where it found a good commit, where it found a bad commit, and how it bisected all the way through. So those emails go out when KernelCI actually successfully can bisect to a specific commit. Another form of reporting that we have is our web dashboard. So this web dashboard has been around for a while, so you may be familiar with this already. Here, this is just an example of a recent snapshot. So here it's listing a bunch of the most recent trees that were built, the branch from each of those trees, the build status. So this shows how many builds we did for each of these trees, and then pass and fail, or kind of skipped or unknown status here. So we have build status here, and then test status. So for each of these trees, we see how many test plans were actually run on each of them, and then a failure count, and so on. So then clicking on each of these lines will take you into a little bit more detail of these views as well. So this is kind of the existing KernelCI view that's been around for a while. The test results, we've been running more and more tests, so you may not be as you may be familiar with looking at builds and boot reports, but now we're doing a lot of tests as well, so you can look at those as well. But just browse over to KernelCI.org on your own, and you can browse this and see what you can find. And we're welcome. We would love feedback and opinions on how this works as well. We're well aware of its limitations, but we would love some opinions as well on how to do it better. So here's another example of, this is the link in the email report for the bisection that I mentioned before, or for the regressions email that we looked at before. This is the link that would be clicked on. So here is the web view of the same thing, where it shows the same 3 platforms down here that actually failed. And it tells you the same type of information. But then here from the web interface, you can click on each of these sections, and it will take you to more details about the platform, including a way to download the whole the whole boot and test log, so you could look at yourself if you really want to see what happened. So here we can also see the total number of tests that were run. So out of the 400 or so tests, 3 of them actually have new regressions. So again, this is all browsable from KernelCI.org, or from the links that come in the email reports will take you to views like this, where you can dig in more detail, have access to the logs, and so on. So Khouloud mentioned the Kcidb. So Kcidb is kind of a parallel universe for storage that we're in the it's been a work in progress that we're now bringing into production soon. It's kind of our new way of storing, a new schema, and a new cloud-based storage. So we've also been experimenting with new web dashboards that are built on top of Kcidb. So this is a quick view of the Grafana-based UI that we've built on top of Kcidb. So at the top of KernelCI.org, you'll see a beta section for Kcidb, which will actually take you to this Grafana interface. This is a new kind of work in progress proof of concept that we're exploring to build better, a little bit more usable web interface as well. So again, we'd love some feedback, opinions. If you're a Grafana developer or a cloud database person, we'd love some help on these as well. Right, so that leads me into this. So what's next for the reporting side? So we are well aware that our UIs are and our web dashboards are pretty primitive, which is what you might expect if you have web dashboards built by kernel developers. So we are looking for help and begging for help from people that want to help us kind of modernize our UI and user experience. So again, as we've been begging for help all through this presentation, if you have a interest in helping our project and you have some experience here in doing kind of new web designs, especially kind of analytics type of web dashboards and UIs, we'd love some help. I mentioned that we're migrating towards using Kcidb for the rest of our backend and storage as well. And then another thing we're working on is having email reports that are a lot more customizable, so people can select just the types of things they're interested in and get more specific email reports out of that. Again, these are all more things on our wish list, not things we actually have the resources to work on at the moment, but want to highlight areas that we know we can improve in, and we would love some help. So to summarize, our kernel patch has gone to school as it's grown up through all of its phases of life, from the mailing list through all the different trees, and hopefully makes it all the way through its rough times in Linux Next and mainline, and then hopefully graduates. So after many times through KernelCI school, we hope that it learns enough lessons and gets a good enough education that it can graduate into LTS someday. But it requires many trips through KernelCI school to get to that point. So here's a few ways that you can catch up a little bit more with our project, what we're doing, how to get involved. You can follow our blog. You can follow us on Twitter. If you want to get involved technically, we have the mailing list, IRC. We have a weekly technical call as well that's open to the public. You're welcome to join, as well as you can follow things on LinkedIn as well. All these are ways you can get involved. You can also reach out to us personally if you like. And a few credits for the photos. So with that, we can move on to the question and answer time.